Hi, I'm Chris Poore from AIS. In this video, I'll be going over the remote sensor node updates for FISSURE, the RF framework. I'll be giving essentially the same talk that I would be doing in person at the RF Village on Saturday, August 10th, 2024. I'll start out by giving you a recap of what FISSURE is, why I think it's important. Then I'll walk through all the remote sensor node updates, and then we'll open up FISSURE and show you how to configure a sensor node. I'll show you all the different ways you can transmit and receive signals. Then we'll walk through some additional new features. And finally, I'll go through in more detail the target signal identification tabs that were recently added. There hasn't been any videos describing what they do yet, and I figure that's a good way. This could be a good way to show you that. But first, I'm a senior reverse engineer at Assured Information Security. I'm part of a team that does security testing, functional testing, research, penetration testing, offensive, defensive, cyber. I specialize in RF, discovering vulnerabilities, gaining access, reverse engineering. I do a lot of forensic testing and administering RF collection events. In the past, I've done a lot of radar collections and analysis and things like that. But now it's more commercial and offensive, defensive, cyber for the government. I also develop open source software. FISSURE is a prime example of that. A little bit about AIS. We're a cyber and information security company. We're headquartered in Rome, New York. We're a government contractor, but we also do commercial work. We have a couple hundred employees. Our core capabilities are advanced research. We do a lot of AI, ML type work, cyber operations, a lot of offensive, defensive work too. Intelligence analysis. We do a lot of software development on lots of different government platforms for collecting all kinds of intelligence. Security testing, that's what I specialize in. You'll see some of what I do rub off on FISSURE here. And trusted systems, we do a lot of that. We have a lot of good products in that realm, and virtualization as well. Check out our website to learn more about us if you have any more questions. But let's get into FISSURE. So FISSURE is our open source RF reverse engineering framework. We showed it off at the demo labs a couple years ago. It contains hooks for a lot of different categories. It helps people walk through the RF reverse engineering process. So it starts with monitoring, collection, replay, analysis, research, demodulation, injection, vulnerability analysis. So each one of those categories can have lots of tools and algorithms and things to help you get through that step in the process. And that's what I mean by hooks for a lot of different things. So we have places to put those new algorithms, those new techniques in this framework to help people get through the process. It started out as a way to speed up the characterization of signals and the identification of vulnerabilities of RF protocols. But since its inception, we've grown it into an all things RF toolbox. So we keep all our scripts, our flow graphs, our reference material, our third-party tools, all our installer information in one place. FISSURE is mostly Python and PyQt. It comes with a out-of-the-box, transparent, pain-free installer. It installs hundreds of third-party tools. It kind of takes all the problems that go with installing these different types of software and it just throws them away. It's a nice, easy way to install this software, and it's repeatable. You don't have to worry about it. And as always, we seek to get more contributors, promote collaboration, foster education. This is a public tool. We want the public to contribute. We want to get your knowledge and use it to help us and help you We're doing this for benevolent reasons. Yeah. Why is FISSURE important? Well, as I mentioned, you can stage your computer with hundreds of tools. You can avoid starting from scratch each time. I've seen people waste days trying to install some of these software tools and having all kinds of errors along the way. Reduce, reuse, recycle your code to eliminate waste. So if you do something, you can put it in FISSURE and it doesn't go away. There's no brain drain. What you do will last for years to come. And you can learn about different technologies. FISSURE is a great way to learn about all kinds of wireless topics. And there are lots of menu items and reference material for you to search through, and you might pick up something you've never seen before. And as you use FISSURE, you can discover areas for improvement and contribute your ideas. We're always looking for contributors. And FISSURE gives you a way to build something, advertise it, get famous, find meaning in your life. A lot of people work on RF technologies, and I know that these topics have been done 100 times over. There are great solutions out there, but this is a public solution. You can take what you've learned in your other jobs, you can apply it to this framework, and other people will use it. It won't be hidden away as a product somewhere that gets sold, or it's for the military or the government. I mean, this is something that everyone can everyone can use and benefit from. So yeah, share what you've done. You can network with others, grow professionally. You can say, I've contributed to FISSURE. We use FISSURE to prove out this point, or we've used it as a test bed for our own research. There are a lot of things you can do with FISSURE. What makes it unique? The open source nature of it. It's on GitHub. You can easily share it with your partners, share it with your coworkers, your collaborators. You can just say, hey, download this. We're going to use this as our starting point. FISSURE also provides flexibility in hardware and software. So you can have cost-effective solutions. You can have COTS radios, COTS devices, computers. And the software can interface with different things on your network. You can make a wrapper to provide messages to FISSURE and get outputs and inputs. FISSURE can also bring together a community. Like I said before, a lot of people are doing this type of work, and there are only a few public places where people can come together and contribute, and this is another one. Plugins, eventually FISSURE will have plugins to help protect data. So if you have certain protocol information, attack scripts, anything that gets added to the FISSURE library, we can make a plugin someday. So if you don't want to share it with the public, you can still use FISSURE and then import whatever you've developed or whatever you're trying to protect from the public. As I said, FISSURE is maintained by a cyber information security company. A lot of these RF tools don't have that aspect to it. So as we fill out all the RF pieces, we'll lean more into the cyber, and then that's where we'll do more complex things in the future. The nice thing about AIS is that they contribute IRAD funds for internal advancement of their projects. So if a customer says, we have this need, can you try it out for us before we do anything formal? We can say, sure, we'll do an IRAD for it. Or if we have an upcoming project coming up and we want a head start, we can put in the work ahead of time. So that's a nice benefit for AIS. And we've already established a steady stream of FISSURE-related projects. So FISSURE will continue to grow. It'll continue to be more operational. We will fill it out. It'll get better. It'll do things. It's just a matter of time. The more projects we can work on, the faster it gets developed. The more contributors we have, the faster it gets developed. And finally, we have AI ML experience at AIS. It's one of the things we do. There are a lot of different areas that we can add AI ML into Fissure, not just classification and all that, but we can do it on the bits, we could do it on the vulnerability analysis pieces, automation of the whole thing. So there's a lot that we can do. Let's get into the updates. So I will be going into more detail about the remote sensor nodes and the target signal identification tabs in the slides here. That's why they're highlighted. But we've also added auto run playlists. So that's a new way to kick off multi-stage and single stage attacks at the same time. That's part of our sensor node features. So like if you start up the sensor node, you can do a auto run playlist on startup, or you can do it through user interaction with the dashboard GUI. There's also file navigation to and from the sensor node. So if you want to save something locally on there and then download it, you can do that over the network. Or if you want to push something up to the sensor node. We've refactored the code base. Everything was one big blob before. We've split it up. We've changed the communications a little bit. The formatting of the messages, the structure of a lot of different things. So we're continuing to flush that out. If you look at the code in detail, you'll see a lot more like source code separated from the rest of it. We'll continue to do that. It makes it easier for people to contribute, and it makes it easier for us to handle pull requests for things. And it's easier to load up in an editor. I've added an on-off keying generator. So if you want to quickly test simple devices like a garage door opener or like something on a remote, you can prototype that pretty quickly and save it to a file. We've added installation setups for the Raspberry Pi and Ubuntu ARM. We were doing that on Orange Pi at Ubuntu ARM. We're working on Python poetry to help separate the dependencies for Python, and we're looking at different ways of packaging up Fissure. One of them is poetry. We can do things in virtual environments, Dockers, VMs, that kind of thing. We're looking into that. That's still going on. We've added enhanced logging capabilities, different levels, like debug, info, error warning, that kind of thing. Triggers. We've found a way to trigger different electromagnetic effects for the single stage, the multi-stage, the auto run playlists, the archive playlists. So we can do any kind of script that connects to a sensor or some kind of input, and then once it satisfies some condition, it'll kick off the effects. So I'll be going through all this in the demo. You'll see it all. But first, let's go through some of the more nitty-gritty for the remote sensor nodes. What I mean by sensor node is general computing. It's a general purpose computer that supports different types of radio peripherals. They don't have to be just SDRs. Anything that you plug into a computer or you control with a computer, it could be via USB or any other input source. And these can be different types of visual, acoustic, electromagnetic, environmental sensors. The sensor nodes run scripted playlists on startup or through user interaction. The auto run playlists I mentioned earlier. It also saves data locally. It maintains the existing Fissure capabilities. So whatever Fissure did before, it still does. You could still spin up a local sensor node and it acts the same way as it did before. So Fissure can be on a standalone workstation. You can be run across a local network to communicate with these nodes, or you can do it over the internet. Some of the benefits of this approach are low-cost, versatile hardware options. We can swap things out based on the mission need. Maybe you don't need a certain type of radio for something simple, or maybe you need a better radio for something more complex. And there's also flexible software flexible software that is easily acceptable for integration. Let's say you want to use someone else's computer that's already on a platform. You can just load the software onto there and maybe attach a radio or something to their computer. So the software is flexible. You can have different things controlling the dashboard. It could be through a phone someday, or maybe you want to mesh network some nodes together. So it's flexible in how we set it up. Right now, it's a pretty simple example of networking and what it does. The open source nature of this approach is unique. It's a great place for people to get started. It's a great education and training tool. One thing that's great about it is I started working remotely, and now I can still do in-person testing of systems remotely. Well, it's not really in person anymore, but like if it's in the office, the thing I'm testing, I could set up a FISSURE sensor node with these radios plugged in, and I can network to it and do remote testing of this device, just like if I was in person. And also, if we're in a different environment, different international localities, laboratories, test sites, we've recently started working with an IoT lab here in Rome, New York, that we're helping manage with other partners through the Air Force Research Lab. So we can set up these nodes in that lab. I'll talk about that more in a little bit. And we can access them over the internet, and we'll have access to these devices that are in the lab. So any IoT thing we want to test, we can do it remotely, and anyone else, any other partner can log in and access that device too. And as we develop FISSURE, we'll have the ability to do different geospatial scenarios that these nodes unlock. So if you want to do direction finding with multiple nodes, tracking, intrusion detection, mobile deployment, perimeter defense, by having these remote nodes, we can do that more easily. It take a lot of work to get those carried out, but that's something we can do in the future. Here are some examples of ways to deploy these sensor nodes. We can do them in remote lab environment. We can do them in lab environments on like a Wi-Fi network, any type of COTS radio that you want to plug into these things, offices, labs, classrooms, home remote. But we can also use them in different disruptor scenarios. Let's say you want to wreak havoc somewhere or passively collect. Maybe you're waiting for a trigger, and then you're going to send information back somewhere, or maybe you're listening for something, and then you're going to kick off an effect to spoof something or jam something or whatever. So you can envision all kinds of scenarios: drones, vehicles. You can put them in different places of interest, like power plants, gates, tunnels. You can put them in a box possibly and ship them around. War shipping. You can cause, you can cause havoc in a lot of different ways, but you can also do a lot of good things, and a lot of complex scenarios that you can chain together. Here's kind of an example of how you would set something up. So you have a laptop computer that runs the dashboard GUI. It's on a local Wi-Fi network. You can have two different types of, you can have two sensor nodes plugged into that Wi-Fi network. Not plugged in, connected wirelessly. In this example, we have a B-Link mini PC with two SDRs, a USRP, and a Pluto. And you can also have an Orange Pi on the bottom right, connected to an RTL dongle. So depending on the mission, maybe you want something light, or maybe you want something that's pretty low power, or just small, and you want to deploy in an office somewhere. You can change it up however you like. All right, so we'll go through all of that in the demonstration. Before I show you more about the target signal identification tabs in the demo, I kind of just want to give you a heads up on what we'll be talking about. So this is the front end piece of FISSURE that's designed to detect signals and then do initial classification of them and spit out what it thinks it knows to your library for further analysis. So it starts out with the detection tabs, which scan for activity. They identify frequencies of interest. There are different ways that we can scan things. These things exist so that we can add in new techniques. So it doesn't work great, but it can if we add in new techniques. The signal conditioner tab isolates signals from large streams of IQ data. Right now it just works on files of IQ data, but it's a pretty simple switch to make it run a flow graph and do live capture of things and isolate the files. It's just changing the file source to a SDR source. The feature extractor tab will extract statistical features from these IQ recordings of isolated signals, and that's used to build machine learning models, and that's the primary input that gets fed into all the ML stuff. The signal classification tab is what's used to develop these different machine learning models. Right now we just have a simple decision tree and a DNN, pretty simple DNN going on with TensorFlow and sklearn. These are just starting examples of things we can do. But once we build these models, we can test them against unknown signals, identify things like protocols or emitters. We can compare the results from different models at once. We can run them through multiple models and establish a confidence and see how many of them identify it as this or that and what the error might be. And in the future, we'll take these results, we'll store them as part of a database, we'll store the signals, we'll store the feature extractor results, the classification results, and each one will be an entry as a signal of interest, an SOI, in the database. And we'll pass that information to the other tabs, like the protocol discovery tab, where we go in more depth and try to get the bits from it. Or maybe if we're confident we know what the signal is, maybe we want to act on it right away. So that can be part of the attack tabs as part of an automation mechanism, tipping and queuing perhaps. So that'll help us set us up in the future to do more complicated things. All right, so this is the last thing before the demos. I want to talk briefly about Orion. A lot of this sensor node work was done getting this IoT lab, this technology accelerator set up. So we've been building up the RF infrastructure for this IoT ecosystem, really. This is primarily the Air Force's brainchild. We're partners in this role. There are other commercial and industry partners that are involved. I encourage you to check out Orion Assured. It tells exactly what it is. We do a lot of STEM events, a lot of testing. AIS's role is just to provide embedded systems knowledge, bring our capabilities and personnel. We help run the entropy facility, which is a hangar where we have all kinds of space to do these events at. We have drone cage, we have networking, we have LoRa. There's a lot going on there, and it's a way to help transition technology, provide tools for people to use to do their research, to develop their technology. That's what it's for. So FISSURE is a piece of that, but there are lots of other pieces that we're heavily involved with. So check that out. And if you want to work in the IoT space, you could reach out to the people on that website. and maybe it'll help you, maybe it'll benefit you. All right, now let's open up FISSURE. Okay, before we get into FISSURE, I want to show you the installer for it. If you run the install script, it will open up the GUI. It'll give you different options. It'll detect your operating system if it's on there. And what you'll see here are different categories of things that it will install. There are hundreds of third-party tools here for different types of things. If it's not checked by default, it means it's not working. I need to fix it. If you click install and it goes through and does these things, it'll turn green if it works, red if it doesn't. There's a little verify section at the end that it runs. If you are installing a sensor node, the only things you really need are the minimum install, the hardware, the auto tree modules, and compile flow graphs. Everything else is just third-party tools that you can install as needed. Or you can run the whole thing and just do like a normal FISSURE install. It works the same way. It's just a different command that you run when you start up a sensor node. There are things you have to do to get it to talk to the local computer here. Refer to the README, but you have to set up like certificates, make sure they match and things like that. There's a config file you probably have to set up to make it remote versus local. But refer to that. I won't set that up here, but I'll show you how to interact with it once it's going. You can run FISSURE from anywhere in the terminal using the FISSURE command. I have a little video going on the right here with a router, a lamp, a Z-Wave light bulb, an X10 switch controlling the lamp, turns it on and off, and a garage door opener. I'll be using those to demonstrate different things in FISSURE here. If you've never seen FISSURE, there are standalone flow graphs up here for different technologies, things that I like to use over and over again. Here are some tools for different things. There's a lot here. There's hundreds of links and calculators and references and maps. There's a lot there. In the lessons, these are the ones that we've been making, and these are just links to other things that I found useful. Let me know if you have any suggestions. There's a user manual. These will open up local pages, but you can, it's the same as the one that's online, and read the docs. Okay, so what's new here are these buttons on the top. They've been replaced from what they were. If you click new sensor node here, you can deploy a local or remote node. I have a remote node set up listening. It's acting as a server, so if I ping it, it'll tell me if it's up. I can recall the settings. And when I connect, it's a B-Link mini PC with a HackerF plugged into it. This middle section here is used to scan whatever is connected to the sensor node. So you check whatever you think's there, and you click auto scan, and it will find the serial. It's trying to find unique identifiers that I can use throughout the tabs. So if I start a flow graph and I have 2 HackerFs, it's important to get the serial for each of them so I know which one to target when I run something. So down here are just default values for all the tabs. Click add to all, it'll add the HackerF to everything. When you hit apply, it'll select an active sensor node. If there are multiple nodes up here, you just right click and it'll cycle between the two. You can deploy up to 5 nodes, 4 remote and 1 local, or just 5 remote. There is a bug right now. We've refactored the code, and as we're putting it back together, I'm finding things that don't work. The bug is that I can't deploy more than 1 node right now. So I can do a local or remote, but I gotta shut it down and start it back up. I gotta fix that. That'll be fixed in the next couple weeks. All right, so if you have something selected, you'll see options in all the tabs. So you'll have HackerF or whatever you have configured throughout different tabs here, and drop downs. That's new. Let's deploy a local node, and I'll show you how that works. So since there's a bug, I'll restart it. Sorry, it'll get fixed. If you have any problems from things freezing or errors, it's probably going to happen. Like we put it back together from scratch essentially. So there's probably some things we didn't get to. You can just kill Python, kill the program. There are instructions in the README on how to do it, and just reboot it if you have a problem. Launch. We'll probably run into some problems while I'm doing the demo. Give it a second, and it will remember my configuration that I have set up. There's a config file that you can change values for. I got a USRP B210 and a Wi-Fi adapter plugged in. So if I auto scan those, it'll show values for that. I can probe. I can guess. If I click guess, it'll cycle through options. So if I have more than one thing, it'll just cycle through till you think it's right. If I don't have a probe function, it'll show up blank. So if I have no good thing programmed for Wi-Fi, it's not going to show up. We'll add this one to all of them. Let's get started. So let's do some transmit and receive type things to show you what FISSURE can do first. Then I'll get into more sensor node specific stuff. So let's say if I want to turn that lamp on, I can run the single stage attack. Turns the lamp on. If I want to turn it off and on and change the light bulb colors, I can do a multi-stage attack, off, on, Z-wave, random colors. Change the duration so it's shorter. Change the gain. So let's turn the lamp off. The lamp on. And change the colors. Alright, that's a multi-stage attack. There's this IQ data tab that's used for analysis of different things. You can record signals. So if I want to record, I have a switch here that I use to control the X10 switch. I'll record some signals from that. That's at 310. Oh, I don't know, maybe it's at 311. You can change the sample rate. I'll click a button. And it'll capture some signals. It'll probably work better if I'm closer to it. Yeah, there it goes. All right, and we can play it back. You just double click and it'll change your settings up here. So if I want to change the light bulb's color to green, I can replay this file at 9:16. Play. It's green, but it doesn't look like it on the screen. It's green. All right, so that's playback. There are inspection flow graphs. So if you want to just have a waterfall pop up, you can do so. It is a problem on remote nodes. So these GUIs that pop up are going to pop up on the remote node. So it's kind of useless for those. But locally, it works the same as it did before. You just hit stop. There are a couple of different options to choose from here, but you can add whatever you like. Let's go into more transmit receive type stuff. So there's an online archive of signals. You can download collections Here I have a couple separated by sample rate. Delete this. So if I wanted to download a Prius key fob, I could just select an individual file, hit download, or if I want to download the whole collection, I can select this and we'll do the whole folder. And each file has a SIGMF data and meta file associated with it. So this one looks like this. We have these analysis buttons down here. So you get ones and zeros for FSK. You can load up the signals in other tools. So like if I want to view this in Spectrum, it will copy the SIGMF information down here for frequency and sample rate, and it's used to launch this program from the command line. And if I scroll down here, you got the ones and zeros, and it looks kind of nice. So if something like Universal Radio Hacker had a command line option, I could just click a button and open it up and get the ones and zeros pretty quick. But if it doesn't, I don't know how to do it. So make sure you have people have command line options for opening IQ files. That would help me out. And if there's anything that you want to do on this file, like if I wanted to plot a small portion of it, do the intermediate or instantaneous frequency on it, with the ones and zeros. Anything in this plot window, you can click these buttons down here and it will apply these functions to it. So if I want a moving average on this, I can click this a couple times. If I want to throw out every other sample, I can do that. And when I zoom in on it, it'll look a little more clear. A little more clean. All right, let's keep it going. There's an archive replay, which will just replay signals in a playlist. We'll do one after the other. You can change the frequency, sample rate, gain. It will do it all on the same radio. These sensor nodes, let's get into this. So we've added this auto run and file navigation tab. There are triggers. I'll go through that in a second. So what you can do is you can add single stage and multi-stage attacks to this table here, and it'll create a playlist, and they'll run at the same time, each item in the table. And you can export that playlist to the sensor node and say run it on startup automatically, or you can set auto run to false and just click the start button here and it'll start it off. This overwrite default playlist will save the file onto the sensor node. So it's the same if you exported the file, it's the same file. All right, let's give you an example of this. So if I do an off attack, it will give me options to time out this item. So it'll stop after 5 seconds. I can do a delay. It'll start off whenever I say it should. The whole playlist itself can repeat on an interval or just run once. You can delay the start of the playlist. If I do multiple attacks, it's going to be a problem if it's sharing the same radio. So you would either have to do a delay, or you can set up a multi-stage attack to make sure that they're not running at the same time. Otherwise, it's going to crap out when it's just running the flow graphs. So that's why it's important to get the hardware information to make sure you're not doing two things at once on the same piece of hardware. So if I wanted to do, this is good enough. Multi-stage attack works the same way. Add to auto run. It'll show up here as a new line with multi-stage. Remove. Start. I turned it off. If you want to edit these values, once you've saved them, you can just click the view button and it'll load it up in the single stage attack. You can edit the values again, then add it back. You can go through your playlists that you saved and recall values for things. That's it for auto run playlists. Let's go to file navigation. So I've added the ability to look at different folders on the sensor node computer. Right now, it's kind of limited to these. If you want to download a file, you just click download. You'll copy it locally down here. It'll show up. If I want to transfer a file to the sensor node, I can pick a text file, something like this, hit transfer. You'll copy it to the remote computer. You can delete files. This is all happening locally, but it's the same as if it were remote. Refresh. If you download a folder, it'll zip it up and transfer it over the network. You can unzip it, open it up in a text editor or something like that. And that's it for file navigation. Let's go through some other new things we got going. Let's go back to those triggers. So different tabs have these trigger sections. Single stage, multi-stage, archive replay, and auto run playlists have them. And the way they work is you click edit, and there are different categories. You can select different triggers under those categories in this combo box. If I want to do a sound threshold, then let's say turn the lamp back on. It'll wait for my microphone to say something. It will print waiting on triggers every 5 seconds. But as soon as I say something loud, it will kick off the attack. If the trigger is successful, it'll return a 0 and go right into the attack. If there are multiple triggers, it will do them both at the same time. And then if one is satisfied, it will stop all of them and go right into the attack. You just add another row. If I do that. Let's do some more here. So these environmental ones, you need the internet for. So if you want to do Las Vegas, you can validate this format. It'll give you a valid answer if it's right. Sometimes you don't need the state. Sometimes you don't need the country. Sometimes you do. Like if you have Rome, it could be lots of Romes. I get sunrise, sunset, temperature. What's the temperature in Vegas? So if anything goes above or below a threshold, it'll kick off the attack. So if it gets hot out, you can do something. If there's wind, if there's weather, if it rains. Just an internet connection. File system, file modified, folder modified, networking, web server curl. So if you do a get to this address, it'll kick it off. RF, it will use the default hardware that you have selected up for the nodes. Detect cellular tower, that's on an RTL dongle. Detect SSID, let's do that one. So I have a router going on the left there. It's called FISSURE demo. And this trigger will look for that SSID and then kick off an attack. So if I want to kick off like a Wi-Fi attack, this one will reboot the router. You set it up. This one requires you to connect to it. So I got it connected. And what's going to happen is I got it start, and it's going to detect the SSID right away because it's already on. But, yeah, trigger complete. So you can do this for MAC addresses or anything and then do typical Wi-Fi attacks. You can throw agents, collect data, whatever you want. Do exploits. One problem that exists is that if it requires a sudo password when you run a Python script or something, it'll pop up locally here. Or if it's on the remote node, it'll pop up on the remote node. So that's bad because you can't enter the password on the remote node. So what we're going to do in the future is we're going to have a list of supported commands where you don't need to do your password, and we'll do it on the install. And we'll add it to the list there. So that's our workaround for that. But in the meantime, don't do things that require sudo. Most of it doesn't. Most of the flow graphs and things. That one does. Okay. So the router restarted. The lights will come back on. But yeah, you can target different Wi-Fi things pretty quickly. Works just like your favorite tools out there. GPS, if it's above a line or left or right, up and down. GPS point, if it's within a distance to a point, it'll kick off. Plane spotting, if you see a plane flying around. Power threshold, this is a good one. Let's do this one. So I have a remote here for that switch that I recorded the signals from earlier. I press a button, it will kick off the attack. Let's go back to the random colors. All right. Click start. It'll sit on this frequency and it'll wait for something to show up above a threshold. So when I press a button on the remote here, it will, well, it already started it. Never mind. Sometimes I find bugs while I'm doing the demo like this, and I think what's happening is that's a bug. It shouldn't do that. So let's just restart it. Somewhere along the way, it messed up the radio. But it's very quick to get back up and running. I'll show you it works. Yeah, so it is waiting on the trigger. I press the button, and it goes. That's a little better. Okay. Alrighty, what else we got? RDS keyword will look for something on the radio, like a title or an artist field. X10 DMOD, this will look for standard out from a GNU radio flow graph. So if you're looking for a particular message, you can just sit on that with a flow graph, and then when that happens, it'll kick off the script. Okay, we're running out of time. Let's keep it going. Sensor node, timer, visual, we got a motion detector. Okay, well, those are triggers. You can do the same thing for all the different tabs. We've also added an on-off keying generator. So I have that garage door opener sitting there. You can enter parameters, and it will plot out a signal that you can save. So the garage door opener looks kind of like this. It's sitting there on the table. The signals look like this. They're in little bursts of on-off keying, ones and zeros. So if I want to simulate that, I already measured it in that IQ data viewer. So I know what to add here. You plot it. It looks kind of like that. You can save it to a file. Call it gd.q. You can play it back from there. You can also use it in different attacks. It's at 310.8. You hit play. It should kick it off. There it goes. So we've added these general IQ playback attacks. So if you want to load that file in, you can add it to a playlist. Just general replay. Let's go over the TSI tab really quick. So these new tabs up here were added recently, and there's a lot more functionality added. As usual, you can add different bands, scan for signals. We're just looking for frequency, power, and time. You can tune to a specific frequency. Like if I want to tune to 310, this will sit on a constant frequency, and it copies the GNU radio tutorial example. So you can adjust your window that you're looking for, the threshold you're looking for. And then when I use this remote here, it's this guy again, I press the button and it'll show up over there. I think it hops around a little bit as I press each button. Hit stop, goes away. And what you're going to see here are a list of frequencies for that device. Now, if it's something that's hopping around, it's not going to be that useful. You'll see it plotted over here if it's running. But the point is just to find potential things to narrow your focus on. So once I know something's at 310 megahertz, 311, I can use this next tab, this conditioner. If you remember the slides, what the point here, the point is to get signals and classify protocols and emitters based on machine learning. So in the future, what I can do is I can tune a radio to 311 megahertz, then spit out isolated signals. For now, it works on large streams of IQ data saved to a file. So if I have a file that looks like this, where I have about 15 different signals of different types, the signal conditioner's job is to split them up into individual files, 15 files, without any errors. There are different techniques that you can use. Right now, all I have are simple envelope detectors, burst taggers. Yeah, you can see here, this one works pretty well, gets all 15 of them. But other people may want to target specific signals, so you may develop a match filter, or you may do cyclostationary analysis on the signal to just target whatever you're looking for in a huge stream of data. So I'm interested in any techniques that you may have already. These are just scripts that are run on the data. So if you have a script that runs on the data and spits out different files, I am interested in it. You can provide whatever input conditions you need to do that. Things like the frequency or sample rate, whatever. So the way this works is you hit start. It'll take that file. It'll spit out 15 different files here. In a second, there it goes. And each one looks kind of like this. You may have large gaps at the end here. If you want to get rid of that, there's a strip all button. You can say a threshold that if it's above that or below that, get rid of it. So when I hit OK, this file size is going to go down quite a bit. Here it goes. If I look at the same file, it cuts off the things at the end. That worked pretty well. But it's up to you to decide, like, what's the signal? Is this a signal, or is this whole burst a signal? So the technique you develop has to account for all the different types of things you might see. And if they're on top of each other, they have to be separated and filtered and whatnot. All right, so once we have the isolated signals, we pass it to our feature extractor, which will take all these different example statistical parameters, time-based, frequency-based, and it will run it on all the data that we collected, the 15 files. It'll go through them all, and it will print out the values. So these are used to build the models, and then we can run unknown data against those models. This data. So like if we did this on an unknown set, we would take this and we apply it to our model, and it'll classify what it is. In here, you can preview the signal. You can plot a column for this table here. You can do the average. You can compare two different values. You can trim it so you can get rid of data above a certain value. So you get junk data, you can just get rid of it all. Remove a row, column, export it, whatever. So once you have this information, you can copy it. Button, copy it to this training tab in the classifier tab. And what you got to do is assign truth to all these values if you're training a new model. You have to know what it is to say that's what it is. If you want to generate more data than what I have here, so like if I have 15 base files and I want to alter them a little bit, maybe change the amplitude, add some noise, whatever. There's an archive dataset tab here. You can add individual files if you'd like, IQ files, and when you hit start, it'll modify those files based on whatever you have checked here. I have one already made out. I'll show you what the point is. Imports, yes. So if I have 5 of each type of signal, I can assign truth to it, and I can randomize what happens to it, and I click start, and it'll generate all the copies of this. So if I want to import it hundreds of times, if I want hundreds of files as a result, I can just keep importing the same file here. FISSURE classifier. And I just doubled it. So you keep doing that, you can grow a pretty big sizable data set. Click start, it'll generate hundreds of files that are altered. Okay, so back to here, you can import that list here. Let's import something I already made. Results truth. So I have all those files, I have the truth assigned to them, and from there I can train new models. Right now, all we have are decision trees and deep neural networks. The way the decision tree is, the way that works is it picks whatever parameters, whatever features it likes. So it'll pick one, then it'll assign value and use it to classify whatever the device is. So D-Wave. But it can get pretty complicated, and it's up to you to figure out which ones work. You can view confusion matrices once it's saved, or as you're testing it. You can run this data through your model just to see give it a quick look to see how it does. If you want to generate a brand new one, you can select retrain here. You can change the different values. So like if you want a depth of 6 instead, maybe you want to uncheck certain things. We'll make a brand new decision tree. You'll spit out the output, tell you what's right and wrong. It'll give you an accuracy value. And if you do it again, it'll say it's much worse. So it's up to you to decide which features you want to use. Some of them have different implications. You can view the decision tree. It should have 4 levels. 1, 2, 3, 4, maybe 4 or 5. Then you can save it. Yeah, so you develop the model, try to get the accuracy better. The DNN, you have to choose a target. So the way it's set up, it's like a yes or no. Is it a Prius fob? Yes or no? Retrain it. The models look a little different. You can load up other third-party tools like Netron here, and you can see what was used to make the model. So if there are any third-party tools that you use for AI ML type work, I'm interested in that. Like if you use TensorBoard or Yellowbrick tools or something like that, something I can export and import, some common structure, file format. I would love to use that. Okay, so once you have your model, you can take your unknown data and run it against your model. So this is all the stuff from that frequency extractor that we haven't assigned. We don't know what it is yet. We don't know the truth behind it. And you can choose your different models and run it against it. Or you can autofill. So anything that has the right parameters in this table, it'll say it's a valid model. So right now I selected everything, so everything should have it. And then when you hit start, it'll run all the unknown data through all the models and give you your results. And they won't always be the same. And this will say if it's a fob or not, so that may not be helpful. The end result will be a confidence value based, it'll say 75% chance Z-wave because I worked on 3 out of the 4 models. So it's not great. It's not very scientific. It can be better. You can develop more models that work better. But that's the idea. You take the unknown data, you run it through here, you get the results. You take this confidence, you take the IQ files, take the features, you pass them on to the protocol discovery tab, and you use that to learn more about the protocol, get the bits, do attacks, that kind of thing. All right, so that's all I want to cover for this video. Stay tuned for updates. We'll go back to the slides now. Okay, I want to return back to the slides for a second. Let's wrap things up. So the outlook for FISSURE, the things we want to do in the future, we want to complete the roadmap that's on the GitHub. There are 3 phases. We got to check all the boxes. We want to participate in more RF simulation events, coalesce the online archive of IQ files, maybe do more with SIGMF, with IQ Engine, that kind of thing. Just we're gathering up this archive. There are ways we can share it better with the public, probably. We want to continue to test the code through remote assessments, extend to academia, create classroom exercises for different topics, support new GNU radio versions. I know 4.0 is coming out or it came out already, so we got to support that. And produce more videos for YouTube and Twitter/X. We have a lot of different topics that we haven't addressed yet and that we can make helpful videos for. And we want to experiment with these remote nodes, use them in different scenarios, put them on different payloads, see how well they perform, and see what we can do. We will improve FISSURE by using it. So the more we can do, the better. If you want to learn more, you can go to our website. There's the GitHub page. It's the primary source for all the information. We also have a page on ainfosec.com, and we have a YouTube channel. So I encourage you to check that out. And that is the conclusion of the presentation. I hope you enjoyed this. If you have any questions, reach out to me. I'm here to help. I want to hear from you. If you have any issues with the software, I want to hear about it so I can fix it. Any ideas, I'm willing to hear it. And thank you. I look forward to making this do more. Thank you.